signs. Here we go. Here we go. Number one. You may have a snow day tomorrow. Who knows? Okay. So right now we're in a winter weather storm. Warning or watch. One of the two, doesn't matter. It's going to change, possibly. It's either going to become not serious or it is going to become serious. So if you get to that point where you have a snow day tomorrow, your e-learning assignment is going to be to do this worksheet, which means we got a couple examples to get through and we've lost a little bit of time. Second of all, if you sign up for your Riverland courses, please make sure you check to see that you were signed up. I did have a couple students, not in calculus, but a couple students, when I went to enter grades at the end of the quarter for college algebra, I had some students who were not signed up. So I think that they've been fairly forgiving about that situation, and they've allowed them to add later on, but it's possible that there could be a time where they don't allow that, and then you took the class and you didn't get the credit. Get my point? So I am your instructor. I am not responsible for you being registered for your classes. Do you understand that? I would like to help you. I'd like to advocate for you, but I'm not checking that website that you were on. Okay? If you'd ever like to check to see if you're registered for a class, actually, tell you what, if you guys remind me sometime, I'll just pull up on a date and show you everybody who's registered in my class. I think I could do that. Can you guys do that? Yeah. If you remind me, we'll check it out, and we'll verify everybody's entered. If you remind me, we'll do that. Okay, here we go. Infinite number of rectangles. Area added up. Morgan is here. She is ready to go. Love the sweater today. We want to use this guy right here, the function 2x minus 1/2 x squared. We're going to find the area bounded from 0 to 4. We're going to put it all together today. You are going to have enhanced learning and understanding. You're going to be great and good to go. You tell me, what is the width from 0 to 4? So if we have n rectangles, what's going to be the width of each rectangle? So we have delta x is equal to 4 over n. Remember, we use this formula. Delta x is equal to b minus a over n. And then we had x sub I is equal to a plus b minus a over n times I, or delta x times I. Okay? So that's the first question. What's the width? The second question is, for what x values do we evaluate the sum? So it's this guy. What is x sub I equal to? Anybody? 4i over n. Because a is 0, and then b minus a over n was 4 over n. We multiply that by I. So 4i over n. We all on the same page? Good. So the definite integral from what to what? 0 to 4 of dx. Good. That is the calculus expression. We're going to express that as an infinite limit of Riemann sums. Riemann was a great mathematician. Limit as n goes to infinity of the sum from what to what? So that's the first rectangle to the nth rectangle. And then what goes after that? Who can tell me what I place after that? Four I over n goes in for x right here, right? So the difference is there's 2 spots this time, right? Okay, so we have 2 times 4i over n minus 1/2 times 4i over n squared. So this is the sum of our heights right here. That's what this expression is. The sum of our heights times, what's the last piece? Delta x, which is 4 over n. So that's the setup. I'm going to pause. Does anybody have a question how I came up with any part of that? That's what we wanted to kind of come to your brain yesterday and say, I could do that part now. Now it's just the algebra. So now you know how to set up the pieces. It's just the algebra. So We got to work with this guy right here. Let's do it. Limit as n goes to infinity, sum I equals 1 to n of, let's figure out this thing first, and then we'll multiply by 4 over n. So what are we going to have? ai over n minus, good, 16i squared over 2n squared times 4 over n. I'll distribute the 4 over n now. What do I get when I distribute the 4 over n? 32i over n squared. Notice how the n is 1 degree larger than the I. That's what you want. Minus can we just reduce this to 32 32i squared over n cubed? So what's different about this example compared to what we worked with yesterday? There's two terms, right? Here's how we handle two terms. It's no big deal. It really isn't. We write it as the limit as n goes to infinity of, I'm going to factor out the 32 over n squared. At 32 over n squared times the sum smartboard. Thanks for making that quick today in the auditorium. I appreciate that. There we go. Sum from I equals 1 to n of what goes here now? Just I. And then we'll subtract 32 over n cubed. Sum from I equals 1 to n of I squared. So I took this sum and I separated the sum into two parts. So this subtraction, I basically just said we're going to do the sum of that, and then we're going to do the sum of that. Okay, you can do that with the summation piece. The rules and laws of the summation pieces, that's something we would love to have spent more time on last year. It's one of those things that gets cut from our standards. It's one of the challenges I have with reducing our the number of things that we teach, because some things get lost along the way. Some people just don't know how much this stuff is used as we move in the future. So anyway, so I've got to replace this. So I've got the limit as n goes to infinity of 32 over n squared times what goes in for this red thing right there. N times n plus 1 over 2. Minus. Lindsay's like, let's go. Minus, I have 32 over n cubed. And the question is, what goes in for that guy? N times n plus 1 times all over 6. Sweet. Can we find that limit? Let's go. Limit as n goes to infinity of, what is this piece going to be? 32 divided by 2 is going to give me, so I'm going to have 16 n squared plus Sure. So I'm going to choose to. Okay, we won't do that. We'll change it. Let's just multiply the whole top through. Okay. We'll go 32n squared plus 32n over 2n squared. Now, pause. So I'm going to keep the top like it is, and I'll keep the bottom like it is. If you would like to start reducing ahead of time, for example, that n and that n squared will reduce already, right? And this 32 over 2 will reduce. If you want to start reducing a little bit ahead of time, you can. For the sake of this, I'm going to just keep the top, and the bottom, okay? All right. Minus, and then I have this guy over here. Ew. Kind of icky, right? Well, we've done it before. N times 2n will be 2n squared. Times n will be 2n cubed. Times 32 will be 64n cubed. And then we've got our middle pieces. So I've got 1 times 2n and n times 1. There'll be a 3n in the middle, right? Times n. 2n squared times 32. 96n squared. And then what on the end? Yeah, 1 times 1 is 1, times n is n, times 32 is 32n. All over, what's in the denominator? 6n cubed. So we'll take each term independently. Limit as n goes to infinity. What would you like to factor out of this piece? N squared. And you're left with 32 plus 32 over n. And the bottom you're left with are 2n squared. What would you like to factor out of the next piece? N cubed. 64. 96 over n. And that's all over. Good. Hey, this is kind of the fun part, isn't it? I mean, this is where you're like, ooh, I've been waiting for this moment. Because what happens? N squareds are gone. 32 over n goes to, and you get 32 over 2, which is 16, minus, and then here the n cubes go away. 0 and 0. And 32 over 6 reduces to, or 64 over 6 reduces to 32 over 3. And so if you take 16 minus 32 over 3, we're going to get 16 thirds, or 5.3 repeating. How could I check my answer? Yeah, calculate, and we go to number 7. Whoop. But first, I should probably plug in my function, shouldn't I? What is the function? What do we have? 2x? Minus 0.5x squared. And this is just so satisfying if it comes out to be exactly 5.3 repeating. And let's see, we're going to go from 0 to what? And we get... Oh, oh, isn't it just so cool? Good job. Our last one. Last one. Flip it over. Oh. Take 1 minute. Pair and share. What's different about this compared to all the others? Go. 5, 4, 3, 2, 1. What makes this different from the others? Go. Okay, so everybody sees we have the constant of 4. That's going to be no big deal. That's going to be super easy. And you see that it doesn't start at 0, it starts at 2. This is going to be a little bit difficult, but not super difficult, okay? So you're going to see where that comes up. We have 3 parts. You guys are super smart. Away we go. Let's go. What's the width of the entire interval? 3. So therefore, what's the width of each rectangle? 3 over n. Awesome. That is our delta x. We have our width. Now we need to know, where do we evaluate our heights? So we have x sub I is equal to whatever a is, your beginning, plus b minus a over n times I. And so what is a in this problem? It is 2. So we evaluate our heights at 2 plus, what is b minus a over n? We already discovered that. That is 3 over n, so it's 3i over n. So our x sub I is going to be a little bit larger. We have this binomial. You guys kind of got used to just putting an I on the width every time, right? Yeah. Well, if it doesn't start at 0, then you also have to attach the beginning to it. Is there any question on that? Okay, so integral, what to what? 2 to 5 of 4 plus 2x minus 1/2 x squared dx. Is equal to what? Limit as n goes to infinity of the sum from the first rectangle to the nth rectangle. And now what do? Yeah, we take this thing right here and we plug it into the x's up there. So we get 4 plus 2 times 2 plus 3i over n minus 1/2 times 2 plus 3i over n squared. Times 3 over n. Thank you. A lot of people forget that. This expression right there, I mean, that's some serious mathematics. Like, hopefully you realize you're at a point right now where it's like, there's not a lot of people in the world that can actually do that. You know what I mean? Like, maybe 5% of the world can do that. So it means you're really smart. So we have the limit as n goes to infinity. And I might not be able to stay in the boxes here because this is a little bit just larger to deal with. The sum from I equals 1 to n of, okay, can we not worry about, can we just not focus on that for right now? Let's focus on this guy right here. And so I'm going to have 4 plus 4 plus 6i over n. Okay, so that wasn't too bad. But now I got to multiply that out, right? Should we do that on a separate space over here? Just figure out what that is squared. Should we do that? Okay, so 2 plus 3i over n times 2 plus 3i over n. So we're kind of using up our spaces here, but we want to figure out what that is. So what do you get? 12i over n. 9i squared over n squared. Good. So Colin is correct. We get 4 plus 12i over n plus 9i squared over n squared. You okay with that? What do we distribute? And the negative. So what's my next term? Yeah, because you're distributing half. Thank you. So minus 2. 6i over n. Ooh, and beta 2. Thank you. We multiplied the half all the way through. So half of 12 was 6, and then half of 9 was 9 over 2. And beta sees something cool. What do you see, beta? Yeah, I mean, that's really convenient, isn't it? Yeah, that's pretty sweet. So whoever wrote this problem really was looking out for your learning. We really thank that person for stepping up. limit as n goes to infinity of the sum from I equals 1 to n. So now I could kind of, I could probably deal with this 3 over n now, right? Because what do my constants add up to? 8 minus 2 is 6 times 3 over n. 18 over n, good. And then, so that takes care of these, right? So now what? Minus 2n cubed. Hey, we pared that down pretty good, didn't we? Yeah. Do you see how easy it is that you can make a mistake along the way? Yeah, it is. But we're really good at our work. So I'm going to break this into two parts. The limit as n goes to infinity of, and here's the deal. I'm going to break this into two parts and just trust me along the way. But I said everything that doesn't have an I factor out, right? This doesn't have an I at all, does it? I'm going to leave the 18. I'm just going to put the 1 over n out here. If I don't do that, people tend to kind of wonder what happens then. And so I'm going to leave the 18 there. Minus, now what? Sum from equals 1 n of I squared. Good. So what's different about this is I don't have an I, right? I just have a constant. So let's write this where we substitute something in. Look at your sheet. What do we substitute? Yeah, so we just substitute 18n, right? So you look at your sheet, and this thing right here, we have the 1 over n out front, and what I'm going to substitute for is 18 times n. Which is really nice, isn't it? Because what's going to happen? N's will go away and we'll just be left with 18. Isn't that great? It's really nice. Minus, then I have 27 over 2n cubed. And what do I put in for this guy that's in the red? Yeah, are you kind of getting tired of this formula right here? Yeah, I hear you. It's kind of that awkward one, but you know it does work, so we'll use it. So I have the limit as n goes to infinity of. Can we just simplify that to 18? Yeah. Okay, thank you. Minus, and then we'll multiply this guy out. We've kind of done this already. 2n times n is 2n squared, times n is 2n cubed, times 27 is 54n cubed. Yes. But still make sure you show your work all the way through. So what Colin is recognizing is, from our previous work, he's saying it's only the lead number that really matters, right? Everything else ends up just canceling out. So there are times people make a mistake. I do check your work on the test to try to make sure that everything is followed through the rest of the way, but you can kind of just, not worry so much about everything after that point. But we are going to worry because we're excellent mathematicians. We got 2n plus 1n is 3n, times n is 3n squared. 27 is 81n squared. Plus 27n. All over in the denominator, 12n cubed. We are almost done. We have the limit as n goes to infinity of 18 minus, and what are we factoring out? N cubed. What remains? (81 over n), which is, some of you commented, again, those are just going to disappear. So we have this beautiful representation where the n cubes cancel. 81 over n goes to 0. 27 over n squared goes to 0. And we get 18 minus 54 over 12. What is 54 over 12? Both are divisible by 6, right? So we get 18 minus 9 halves, or 36 halves minus 9 halves, which last time I checked was 27 halves, or 13.5. Are you nervous? Like, what if we went to the calculator and it was wrong? Oh boy. What's our function? 4? What? 4 what? Help me. Plus 2x? Minus 0.5 x squared. And I'm going to calculate the area 2 to 5. Oh. Okay. The first problem we went through, okay? As we end, I want you to pair and share your level of confusion on a scale of 1 to 5. Like 1, like I'm not confused at all. I totally got this. 5, I have no idea what's going on. How did you feel the first day, and how do you feel now? Talk. And pause. Very good. Can I have 2 people share? Where were you at before? Where are you at now? Where were you at before? Where are you at now? You were at a 3? Now you're at a 2. So we're really fully confused. You've gotten better. You're almost fully got it. You feel like there's maybe just a small piece. Anybody go from like a 5 to a 1? Yeah, Esther, you went from 5 to 1? I just want to encourage you guys that you got to trust that it's okay to walk away from class one day and be completely confused. And then trust that over time we'll get it. And I'll be honest, it does depend a little bit on the teacher, right? Like, we've talked about that, right? If you get into a college class, if you walk away confused, the professor might just kind of leave you hanging, okay? Which in case you need to kind of, ramp up and figure that out later. So thank you for your patience. Problems 3 and 4, are you able to do those now? Yeah, notice they both start at 0. They just go to 1. I've made them nice and small, but you do have multiple terms, okay? Then if you move along a little bit, you can see that we have for problems 5 and 6, those just one term, but it doesn't start at 0. Starts at 1. This one starts at 2. So those should hopefully be okay. They should hopefully go fairly quick. And then 7 and 8, those are a little bit more challenging. Again, I try to leave them small so they just start at 1 so you wouldn't get really large numbers, but that's what you want to start working on. If we do have class tomorrow, I'll give you some time in class to work on it. But if we don't have class tomorrow, notice we lose Friday. We would lose Friday, right? And then Monday, we don't have school. And then we're going to have do we have a Wednesday coming up where we don't have... You get my point, though, the number of days that we lose, right? Yeah. So I appreciate your focus on a day like today that got interrupted by our registration. We can't afford to lose too much time. So good job. Way to go.